Hello everyone, this is Aditya and today we are going to study greatest integer function and fractional part. But before that, please do like, share, subscribe my channel, please support this video. Now let's start the lecture. So first of all, let's study greatest integer function, that is JEE. So JEE of x, how do we define it? So let's take some example to understand it, right? Suppose x is equal to 3.4, x is equal to 2.9, x is equal to negative 2.7 suppose, and x is equal to 5 suppose. Okay. So in this we define JEE x as 3, JEE x is equal to 2, and JEE x is equal to negative 3, and JEE x is equal to 5. Okay. Okay, I'm telling that why I'm writing all this. Well, JEE x basically gives an integer which is less than or equal to the given input value, right? Which means that we first suppose we are given 3.4 as an input. So which is the integer that is less than or equal to the given input? Well, of course, this is not an integer value, so we have to take the less than value case, right? Which means that 3 is the only integer that is just less than the given value, right? Why? Because see, this is 1, 2, 3, this is 3.4 somewhere here. So which is the closest least integer to 3.4? It is 3, right? Hence we got 3 over here. And in this case also 2.9, which is the closest least integer in this case? It is 2, right? Now many will think that why can't we get 3 over here since we are dealing with integers? No, you have to take the integer value which is less than the given input, not greater than, right? There's another function which is defined to get that value, but we are not discussing that right now. Okay. So in this case, JEE of negative 2.7 is equal to negative 3. Now many will think that negative 3 is greater than negative 2.7. No, negative 3 is less than negative 2.7, right? Remember this, okay? And x is equal to 5 since x is itself an integer. So JEE x will be equal to that number itself, that integer value itself. So from this we can say that JEE x is always less than equal to x, right? Correct? Over here you can check also that JEE x is 3 and this is equal to 3.4. So of course there it is less than that value. And over here, since it has an integral value, so in this case equality exists, right? So basically you can say that JEE x is less than x if x does not belong to integers, and JEE x is equal to x if x belongs to integers, right? And this is a really important condition because it helps us to find many things, right? It is helpful in many questions, so you should remember this one, right? Okay, so now let's see some of the properties of GIF, and then we will see some problems, right? And of course we have to discuss fractional part also, right? Okay, so let me raise this. So let's see the first property. Suppose JEE x is equal to a. Now without any second thought, you must know, you must answer it, that a should belong to real number. No, it should belong to integers, correct? Of course, if JEE x is an integral value, so how can an non-integral value be equal to an integral value? Which means that a has to be an integral value, right? Because this quantity is an integral value, right? So suppose if I ask you JEE x is equal to 3.2, what will be your answer? Just pause, think, and tell in the comment section. So if anyone gave any value as an answer, then you are wrong. Its answer is that there exists no such x. Why? Because this is an integral value. How can an integral value be equal to a non-integral value? Simple, right? Okay. So what is the solution of this equation? Well, x belongs to closed a to a plus 1. Correct or not? Are you understanding or not? Well, let's see. Suppose JEE x is equal to 3. This is a valid statement, right? Okay. So suppose if you take x is equal to 3, then JEE x is equal to 3. Correct? Yeah. Suppose you take x is equal to 3.7. JEE x again is equal to 3. Correct? Suppose you take x is equal to 3.99999. This is also equal to 3, right? But JEE of 4 is equal to 4. which means that it will satisfy in one more case. Suppose x is equal to 2.9999. In this case, GIF, it is equal to 2. So it means that you can only take the values from 3. You can include 3 in that, 2, 4, but you can't include 4 in that case. So x belongs to closed 3 to open 4. That will be the solution of this equation, right? Understanding or not? So any value from 3 to 4, if you take the GIF of that quantity, it will always give 3 as the result, right? Understanding or not? Correct. Okay. So let's move to the next property. But before that, let's see the graph of this function. So how does this look? Well, at 0, 0 to suppose 1, we are drawing this. Okay. I will explain it in a few minutes. Let me draw it. This is your x and this is your y, correct? Okay, let me explain it first of all. See, so on the x-axis, when you are from 0 to 1, if x belongs to 0 to 1, then what is the value of GIF? GIF x will be equal to just the converse of this statement. It will be equal to 0. Correct? Correct or not? It is correct, right? Because if you consider this interval, then in that case, of course, GIF will be equal to 0, right? So that is why from 0, 0 included to 1, the value of the GIF function is equal to 0, right? Y is equal to GIF x, right? Correct? Okay. Now suppose you go from the interval x belongs to open, I mean closed 1 to 2, then that case GIF x will be equal to what? It will be equal to 1, correct? So it means that in this interval, the value of the GIF is equal to 1, correct? Yeah. Similarly, in this case, you can find it yourself. It will be equal to 2 over here, and so on and so forth. And similarly, on the negative x-axis also, it will happen the same, right? This is open. You know that y over here, it is open and here it is closed, because here we are including 0 and here we are not including 0, because its limit is from negative 1 to 0 open, correct? And then we are going from 0 to 1 like this, okay, so on and so forth. So basically it is basically this case only, we are using this property to draw its graph, right? Understanding or not? So basically it goes like a staircase, right? Okay, let's forget that. Okay, okay, now let me tell you another property, and this graph will be very much helpful to understand that one. GIF of x plus k is equal to GIF x plus k if k belongs to integers, right? But why does it happen? It happens because when you add an integral value to this graph, you're just shifting this graph a bit, right? So that is why by integral units, right? So that is why it won't affect anything. You can write it like this. Either you first add that integral to the given input and then take the GIF, or first take the GIF, then add that integral to that value. It won't make any difference, right? So this is also a property which you should remember, right? Okay, let me erase this. GIF x plus k is equal to GIF x plus k if k belongs to what? Integers, right? Okay. Now there's one more thing which you should note over here, that GIF of k times x is never equal to k times GIF x. If k belongs to real number, right? Okay. So why? Let's take an example to understand this. Suppose k is equal to 3, right? Okay. And x is equal to 2.7, let's assume. So is 8.1 correct? So GIF of 8.1 is equal to 8, correct? Now what will be its value? So it will be 3 times GIF of 2.7. It is equal to what? It is equal to 2, which is equal to 6. This value is equal to 6 and this value is equal to 8. So of course they both are not equal. So of course if they are not equal for integral values, so it is obvious that it won't be true for non-integral values also, right? Understanding or not? So that is why I wrote over here k belongs to real number, right? So let's erase this, right? Of course, it is valid only if k is equal to 0, right? But we are not including that case because that is obvious. You are just basically multiplying both sides by 0, right? Okay, let me erase this. Yeah, but there's a possibility that suppose gif of kx is equal to kx. If k belongs to integers, then you can be asked that under what conditions is it true, right? Then there will be a simple answer that if x belongs to integers, right? Because if x is an integer, then in that case you can clearly say that this expression is true. Why? Because gif of, suppose you take any integer value, 3 times 4, right? So of course it will be equal to gif of this quantity into 4, which is equal to 12, and 12 is equal to 12, right? Correct. Basically, if k is integer and x is integer, which means that kx is an integer, so gif of an integer is equal to that integer itself. So it means this is equal to kx, and this will be equal to again kx, right? So kx is equal to kx is always true, right? So that is why for x belong to integers, this value, this expression, this equation is always valid, provided k belongs to integral value and x also belong to some integral value, right? That is why. Understand or not? Okay. So let's erase this. Now let's see for inequality case also. Suppose gif x is greater than equal to a, then there is case what value of gif x we get. Let's see it. So in this case we get x belongs to closed a to infinity. Why? Because a is included in this, right? Correct or not? Right? And suppose do you know how I got this value? Because now here we have infinite values possible for x, right? Understanding or not? And of course a has to be belonging to some integral value, right? Correct. So it means that if gif x is greater than or equal to 3, it means that x belongs to 3 to infinity. Correct? Correct or not? Okay. But if I say gif x is greater than or equal to 3.4, so what will be its solution? Don't say that there exists no solution. That was for equality case, not for inequality. So you can say it is equivalent to saying that gif x is greater than 4, greater than or equal to 4, right? Correct or not? It is correct, right? Hence x belongs to 4 to infinity, right? Correct or not? Is it fine or not? Fine. Okay. And suppose if I say gif x is equal to 3.4, then no solution. Here we have no solution. But inequality basically you can get the answer, right? You will get the answer basically. And over here you will get no solution, because of course it is an integral value, this is non-integral value, how can they be equal, right? Understanding or not? And in this case, if this is greater than this, then of course this is the result from this. Okay, and it's obvious also, right? Are you understanding or not? You can just pause this video and think about it once, right? Okay. Okay, so I can create another case in this. Suppose gif x is greater than a, then x belongs to closed a plus 1 to infinity if a belongs to real number, integral values, integers, right? Why? Because suppose if gif x is greater than 3, right? So if I take x from open 3 to infinity, then also when I take the gif, in this 3 will be included. Why? Suppose you take 3.2. If you take 3.2, gif of 3.2 is equal to what? It is equal to 3. Hence we add 1 to it, right? So it means that x belongs to closed 4 to infinity, right? Understanding or not? So that is why I wrote over here a plus 1. Many wrote like this: x belong to open a to infinity, right? This is clearly wrong, right? That is the correct statement over here, right? Let's check for this case now. Less than equal to a, then how we check it? So in this, x belong to negative infinity to a plus 1 open. Okay, I am telling why. Suppose gif x is less than equal to 3, then what you will get over here? X belongs to negative infinity to 4 open. Why? Because if you take the GIF, suppose you take x is equal to 3.9. In that case, what will be the value of GIF? It will be equal to 3, which is valid over here, right? Are you seeing it or not? It is valid, right? Okay. So hence we get this as the result over here, right? For this one, okay? Now suppose GIF x is less than a, and of course if a belongs to integers, right? In this case, okay? And here also if a belongs to integers, right? Correct? Okay. Over here you will see that x belongs to negative infinity to what? Now pause and think. Correct? Right or not? It is correct. Why? So let's see this one. Okay. So in this we will see that x belongs to negative infinity to 3 is correct. Why? Because if you take 2.9 in this case, right? In that case, GIF value will be equal to 2. So 2 is the maximum value in this case, which is of course less than 3. So this will be our result, right? So you should remember it as a property also, and you should remember the logic also, right? That what logic we are using. Basically we are just seeing the last value of that interval. Of course that is not the last value, but we are seeing the last value which we can think mentally, right? There can be very close value to 3, but we are not considering that one. Okay, we assume 2.9, right? 2.9 is much closer than 2.9. 2.999 is closer than 2.99, and so on and so forth. So we are not taking like that. We're just assuming that yeah, that value is close to 3, so we are assuming like that. You could have taken 2.6 also. It's totally fine, right? Okay, so let's erase this and let's see fraction part of x, and let's see some questions also. Okay, so let's see how we define fractional part of x. Well, it belongs to 0. This is closed 0 to open 1. Why? Let's see it. So basically if you have a number x, it can be expressed as GIF x plus fraction part of x. Wait, I am telling how. Suppose you have 3.4, so it will be equal to 3.4 GIF of 3.4 plus FIP of 3.4, right? Or fractional part. This is equal to 3 plus 0.4. We will take the fractional part of this quantity. So of course this is true, right? Okay, fine. But suppose I give you negative 2.9. Then in this case, its GIF will be negative 2.9 over here plus the fraction of this quantity. It will be equal to negative 3, right? Plus GIF, I mean fractional part of negative 2.9, right? So it's a problem that how we will find its fractional part. Well, many will say that yeah, it will be negative 0.9, right? Since we have a fraction there. And some will say yeah, it's 0.9. But these both answers are wrong. Why? Because we know that it belongs to 0 to 1, and of course it should satisfy this equation also, right? So if you take 0.9 in this case, these two will never satisfy, right? Or if you take negative value, it is not in the interval itself, right? So basically from this you get negative 2.9. The fraction part of this quantity is equal to 3 minus 2.9, which is equal to 0.1, right? Now that's something really amazing, and if you put it over here, it is satisfying also, so it's correct. So basically fractional part of x can be given as x minus GIF of x, right? This is the better way to define it instead of this interval or seeing it as a fraction or a decimal value, right? Because in this case you would have got confused, so it is better to see it like this, right? Okay, so let's see its one or two properties also. Fractional part of x plus k is equal to fractional of x if k belongs to integers, right? Correct? Why? Because of course it will get distributed over here since it is an integer, so it won't affect the fractional part if you are adding an integer to a fractional value, right? It will not affect it, right? That is why you will get GIF of x, I mean FIP of x or fractional part of x, right? Okay, so let's see some problems to understand this more, right? So let's see this problem, but before that let's see the graph of fractional part of x, right? It goes like this. Okay, this value is 1 and this value is 0. So notice that in y 0 is always included but 1 is always excluded, and of course that is the interval in this case, right? And it is a straight line and it has an angle 45 degree, correct? Why it has the angle 45 degree? Because gif x, I mean FIP of x, why I'm saying again and again GIF, its fractional part is equal to x minus this quantity, right? So basically we know that this is a constant. Why is it a constant? Because in a given interval, suppose 3 to 4, in this interval this is always a constant, right? It will be always equal to 3 in this case, right? Right or not? Yeah. So that is why this is always a constant. So suppose for this case we get fractional part of x is equal to x minus 3, right? But x can take any value from 3 to 4. 4 is excluded, right? So what will be its slope? Its slope is equal to m is equal to 1. So tan theta is equal to 1. So theta is equal to 45 degree, right? Hence this angle is equal to 45 degree. Correct or not? Right? And of course it lies from 0 to 1. So that is why it goes like this. It only goes from closed 0 to open 1, right? For every interval 0, 1, 2, 3, 4, -1, -2, and so on and so forth, right? So this is a basic idea. Now let's see this question. So I chose such a question which maximum concepts are being used. So you will get well acquainted with such types of problem because they are very much common in examination, and many times students gets confused in this. So with this problem you will be able to understand most of the things, right? Okay. And one more thing I have to tell, there was a problem, I guess I don't remember in which year or whatever, I can't remember it. So in that they asked fractional part of gif of x plus gif of fractional part of x is equal to what? Now it seems really amazing. Okay, so how will you answer such kind of problem? Nothing. You have to just see what will be its value. Gif x is always an integral value, right? So what will it have in its decimal value? 0, right? So it's equal to 0, correct? And notice this one, what is its value? It lies from closed 0 to open 1. So gif of closed 0 to 1, it will be equal to 0, right? Because in that interval it is always equal to 0. You have seen the graph also and you know it logically also. 0 plus 0 is equal to 0, right? This was a very good question because many students got confused in this one, right? Okay, so this is how you should remember such kind of problems, right? Okay, let me raise this. So first of all, so before doing this one, let's do another problem also. Suppose gif x whole square minus 3 gif x plus 2 is equal to, suppose it is equal to, you can assume it as, suppose over here you have 3 and it is equal to 1, right? Okay, sorry, I'm making questions right now, so I don't remember that what all can be done, but yeah. So gif x square minus 3 gif x plus 2 is equal to 0, correct? So you can factorize this. You can either, if you face problem like this, just assume that gif x is equal to t, correct? Okay, so you get t square minus 3t plus 2 is equal to 0. So you get t minus 1 into t minus 2 is equal to 0. So you get t is equal to 1 or t is equal to 2, correct? Now gif x is equal to 1 or gif x is equal to 2, it means that x belongs to 1 to 2 or x belongs to this quantity, right? So if you do union, you will get x belongs to 1 to 3 open, right? Correct or not? Correct. And of course it will satisfy also, right? Okay, now let's see another type of problem, right? So in this I changed this question a bit only. I changed it from 3 to 1, I mean from 3 to 2, right? So you can just bring it over here, so you will get this quantity. So what will be its root? Let's see it. You are assuming it as t, so you get t square minus 3t plus 1 is equal to 0. Now you apply Sridharacharya formula or Brahmagupta's formula. So you get 3 plus minus root negative 3 square is equal to 9. 9 minus 4 into 1 by 2 into 1, which is equal to 3 plus minus root 5 by 2. Now exam, you will of course see this option as correct, but no, you have to be careful. We are not calculating t, we are calculating t is equal to g of x, and this is not an integral value. So in this case, there will be no value of g of x. There will be no value of x, right? Understanding or not? I told it earlier that how can a non-integral value be equal to an integral value, right? Okay. Now let's change this problem from equal to greater than equal to. Let's take this one. Okay. So let's factorize this one. How will factorize? Well, we calculate that t, if you assumed it, suppose we assume it equal to 0, t square minus 3t plus 1 greater than equal to 0. So let's assume it equal to be 0 to factorize it, right? So you get t is equal to 3 plus minus root 5 by 2. You got this? Hence you get t minus 3 plus root 5 by 2 as one factor multiplied by t minus 3 minus root 5 by 2 as another factor. It is equal to 0. And basically they are the factors, right, of this expression. So you get t minus 3 plus root 5 by 2, t minus 3 minus root 5 by 2 is greater than equal to 0, right? Okay. Now you will use wavy curve method to plot this, right? I said that I will take some problems in which most of your concepts will be utilized, right? So that is why. So this one, it will lie over here, 3 minus root 5 by 2, and here it is 3 plus root 5 by 2. And of course 0 will lie somewhere else over here, right? Because root 5 is like 2 point something, right? So if you take any value greater than this, it should be positive, right? You know wavy curve or not? You know, right? Okay. Understand or not? And if you take any value between this, it will be a negative value, and any value less than this, it will be a positive value, correct? So you can draw like this also if you want, right? So we have to take these values. Hence, t belongs to negative infinity to 3 minus root 5 by 2 included union 3 plus root 5 by 2 to infinity. But again, you should remember that we are not calculating this at all, right? We are calculating g of x. So let's calculate that. Let me raise this. So basically g of x or t belongs to negative infinity. So let's approximate this. Well, root 5 is around 2.2, I guess, if I'm not wrong. I don't remember exact value, but it is like around 2, right? 2 or 2.2, I guess. So whatever be its value, suppose it is 2, right? So in that case, 3 minus 2 will be 1. So 1 by 2. So basically you can say it like t belongs to this expression. Suppose 0.5. Let's assume for now, right? Union 3 plus 2 divided by 2, it is 2.5, correct? To infinity, right? Now it means that g of x belongs to negative infinity to 0, correct? Because of course you can't go to 1, right? Understanding or not? So that is why 0 has to be over here, right? Union, right? Now we want g of x to be greater than 2.5, which means that it should go from 3 to infinity, right? Correct or not? Correct. Hence x belongs to what? Now think logically. Of course it will go from negative infinity to 1. That is that property only, if you remember that one, when we said that it is less than equal to something like that, you can see, right? Union, what will be its value? It will go from 3 to infinity only. Why? Because 3 is included in this, right? That is why. Why I took over here closed, I mean open one? Because 0 is allowed over here. So we can take 0.5 also, 0.6 also, 0.7 also, 0.9 also, 0.999 also for the value of x, right? Understanding or not? So that is why I used over here a open brace over here, right? Understanding or not? So for this case, x belongs to this, right? And in homework you can do like this also for less than equal to, right? Okay, so let me erase this. Now let's come to this question. So we discussed the case for equality, for inequality. Now let's see this most famous problem, right? Okay, so how we do such kind of problems? Well, we basically equate whole expression to fractional part of x in such kind of problems. Let's see it. So basically GIF mod x, or you can say 191 minus 7 GIF x by 23 is equal to this, correct? What I've done is that I just brought this over here. So 191 minus 7 GIF x divided by 23. Now why I did this? Because we know that this quantity lies between 0 and 1, right? Correct? Okay. So it means that this expression should also lie between this, right? Hence 191 minus 7 GIF x divided by 23 less than 1. So we have 23, that is 0 less than equal to 191 minus 7 GIF x less than 23. Correct? Correct or not? Correct? So from this you get negative 191 less than equal to negative 7 GIF x less than 23 minus 191. What will be its value? 191 minus 23, so you get 1, it gets over there, so you will get over here, here you get 6, and here you get 8, right? Okay, so let's solve it. So you get negative 191 less than negative 7 GIF x less than negative 168. Correct or not? Correct? Yeah. So now let's divide both sides by negative 7, and when you are dividing by negative 7, then the inequality sign will reverse. So 191 by 7 less than, it will become greater than equal to GIF x, and it will become this, right? Okay, what will be its value? This is equal to 24, and this is something like 27 point something, right? 27 point something. So it means that GIF x is less than equal 27 point something is greater than 24. Hence GIF x is equal to what? 25, 26 and 27. This is the solution, right, for GIF x in this case. Correct or not? And depending upon the cases, you can solve for different values of the x, right? Since you know that x is equal to GIF x plus this quantity, right? You know how I wrote this? Since GIF x is greater than 24, which implies that GIF x is equal to 25 and GIF x is equal to 26 and GIF x is equal to 27. Since 27 point something is of course greater than 27, so of course GIF x will be equal to 27 also. So let's substitute this value over here. So we get 7 GIF x plus 23, this is equal to 191. So from this you will get three values of this also. When you substitute, GIF x is equal to 25, 26 and 27. Let me tell you one, then you can solve for rest too. So let's take 25. So 7 times 25 plus 23 GIF x is equal to what? 191, correct? Now what is 7 times 25? It is equal to 5, and so we get 175 plus 23 GIF x is equal to 191. So you get 23 GIF, sorry, this is FIP, sorry, fractional part, is equal to 191 minus 175. What is it equal to? It is equal to 16, right? 16. So we get this expression is equal to 16 by 23. Correct? Correct or not? Correct. Hence we get x is equal to 25 plus 16 by 23, right? And you can solve its decimal value. So this is the answer in this case. And similarly you can solve for 26 and 27, right? So you get three answers in this case for the value of x, right? You can verify it also. When you substitute it over here, you will get 175 plus 16 is equal to 191, correct? Yeah. Similarly, you can check for 26 and 27, right? So I so that now this topic is clear to all of you. And of course, if you have any doubt, please let me know in the comment section. Bye bye, take care, and all the best.